Let's solve the question count arrays. In the question, you'll be having an array B of size M, and B is called good if you can make all the elements of B equals to 0. Now you have to form like how many ways you can form the array B such that if you perform these operations on the elements of B, you can make all the elements as 0. Now what are the operations that you can perform is you can select any two elements I and J, and you will have to do a OR operation of both the elements. Now you got a OR operation result. After that you have to, like if you're standing at the ith index, then you have to do that OR result minus the element present at the ith index, and for the jth index, that the OR result minus the jth index. So let me make it more clear.
In the question, we are given with n and k only, and we have to find the number of subarrays, number of arrays that we can form of length n, so that each and every element of this array would be less than 2 to the k. So what this k is saying, this k is saying that the number of bit positions where we can use set bits is k. If we are considering like k equals to 0, then 2 to the power 0 is 1, so and k is 0, so that's the first position. Like we cannot use set bit at any position if k is 0. Whatever the value of k is the number of places where we can use set bits. Use set bits because placing 0 is always possible. We can always place 0 at everywhere, and now each element is consisting the value 0, so it's the valid one. But how can we place the other values? So in the question, we are always performing the XOR of each and every element of the array. Let's say the array is B, we are always performing the OR of the two elements of the array, and then bi we are replacing with x minus bi, and bj we are replacing with x minus bj. So what this is doing is, this will be containing all set bits present in both, and this is containing set bits after the operation present in j only, and this is containing the set bits present in I only. So what we have noticed, the common bits got cancelled. Now we are left with the bits that are present in only j and only I. Now the common bits got cancelled out. So what we have noticed, if some let's say at the ith set bit is present in the element this as well as this, so if it is present even number of times, so if we are performing the OR operation, this two common bit will definitely get cancelled out. Like in the pair of 2, they are getting cancelled out. Like as we have chosen I and j, then those common bits got cancelled out. So if we are using any set bits at any bit position, let's say the bit position are like, these are the bit position for the element at the first index 0 1 2 3, so these are the bit position for the first element, second element, third element, fourth element, so on and so forth. So if we are using set bit at the third bit position, then we have to use this even number of times. So we can put at 3 also, or we can put at 2 also, but it should be even number of times, so that in a pair of 2 they will get cancelled out, like common bits are getting cancelled. So we have to cancel each and every bit should get cancelled out to have a 0. So our motive is to get a 0 only. So if some bit is present in even number of times, so by making a pair of 2, they will definitely get cancelled out. So if we are having n numbers, So we can choose any zero, like two, like the zero elements to put a set bit, or we can choose two elements, like we have in total n elements, so we can put set bit in the two elements, or we can put set elements in the four, or we can choose six, like we can choose even number of times, so on and so forth. And this is we have to do for every k bits. Now this is for the zeroth bit. Now the same would be for the first bit, second bit, so on and so forth. So what the sum is, if you know the sum of this nc0 for all the even numbers, so this is 2 to the power of n minus 1, the sum is. Now this is for the zeroth bit. Now the same would be for the first bit, 2 to the power of n minus 1, that is n is the total number of elements. For the second bit it will be 2 to the power n minus 1. So this is for the zeroth bit, this is for this first bit, for the second bit, so number of ways, and we have to merge this. So what we'll be doing, we'll be multiplying all the ways, like for the zeroth ways. Now if we are combining both, so how many ways would be? By multiplying this 2 to the power n minus 1, so how many times? So k times. In the simple words, we can do 2 to the power n minus 1 to the power of k. So this is our final answer, and we will print this. So that's it.
What I have done in the code is first I have taken input n and k and then initialized answer with k. In the question it is said that the value for each an element should be less than 2 to the power k. It means you will have k bits where you can put the set bits. So you have k bit positions, and for each bit position you have 2 to the power n minus ways to put your set bits. So that's it. Like for each and every bit, you have 2 to the power n minus 1 way. So you'll be multiplying this k times. So that is basically 2 to the power n minus 1 to the power k. So that's we have printed out. I hope you like it. Thank you for watching.